Okay, I think we are almost done with the technical difficulties for today, hopefully. Okay, hello everyone. My name is Kristine, as Thomas just presented. I'm a Ph.D. fellow, currently working in the DecomBlades project. I'm employed with the University of Southern Denmark, and I'm representing us today, where I would like to present to you the use case scenario from DecomBlades that we've been working on together with all our partners. So even though I'm the one presenting, then this is actually the result from a lot of people's hard work and input. Yeah, I mean, we are a little bit behind on the schedule, but I would really like you to think about questions in the meantime, so we can take those after, so it can become a bit more of an open discussion. So please keep that in mind whilst I speak. So, very briefly, I'll explain to you why or what is the expected outcome of this exercise, and also through that, why did we actually choose to approach it this way? Then, how did we work on it? What is the actual use case scenario? What are the methods we are applying, and what is the documented value chain that we have identified so far? Finally, the next steps. And the reason why I put this picture on, this is from one of our workshops at Vestas. It was last year. I unfortunately don't have a newer one, but it's just to represent that the way we work in the DecomBlades project is through many different workshops where everyone participates and provide input and data and so on, so it's very cooperative, and I think that's key for the outcome of the project. So, expected outcomes, why we're working on this use case. We heard previously that we have three main technologies that we are looking into, being mechanical processing, pyrolysis processing, and cement co-processing. And in order to actually create a baseline for a fair comparison of those three technologies, we need to set certain parameters or specify them so we can actually conduct this analysis and not getting influenced by all kinds of other factors that are not actually you can say relevant for the evaluation of the technologies. So we want to have a baseline, and we want it to be fair. That's the aim. We also expect that this will provide guidance for the technology developers and technology owners to actually know how to keep working with their technologies. It also helps us identify where in the value chain are we actually creating impact, both environmentally but also from a cost perspective. And again, this will highlight to everyone where are the main focus areas moving forward. And then finally, this will also give us an early estimation of environmental impact versus cost. And this is something we've discussed as well. Is it worth investing more money to get an even better environmentally impact for our technology, or how should this trade-off be? And before we actually know, then we cannot have this discussion. Yeah. So the approach here, very briefly, just for the use case, is we had a number of workshops with the 10 partners. We decided on the use case together. And then we took over months several iterations of data gathering through several meetings and so on with the partners. We gathered all this input at SDU, and we have done preliminary analysis and results, which we then go back and share with the partners of the project and evaluate between all of us. So the actual use case scenario we decided on, and I'll just step down, is 30 blades from LM, being of the 48.7 meter long blades. And we decided that they were, as a baseline, located at the port of Esbjerg. We're also very close to that location today, because we know, as was just mentioned before, that moving forward, this will be one of the main locations for that in the future. It is important to say that this is not a current case, meaning that LM does not actually have 30 blades lying around in the port, but it is a very realistic scenario moving onwards, and that's why we use that as a baseline. And furthermore, LM also actually had one blade that we could use for the project for testing. So I'll come back to that, but that is also a part of it. Then the 4 scenarios we'll investigate, and I'll come back to those in more detail, but that is landfill for baseline comparison reasons, what is actually what's available today, and then compared with the mechanical processing, pyrolysis processing, and cement co-processing. So those are the 4 scenarios we are investigating using these standard information or baseline information. Finally, just to clarify, we have assumed the same geographical locations for the end processing facilities. And again, that is not the actual case, we know that, but right now we don't have the facilities anywhere. So in order for transportation not to be one of the, you can say, the deciding factor or the thing tipping between the different technologies, we assumed that we would use the location in Bremen, where up until recently, Neova and Holcim had their plant for cement co-processing, because that was currently the only alternative we really had to landfill, and therefore we thought that is a good comparison. So moving onwards, we are assuming that these facilities are actually in Bremen. Yeah, and again, you can question that, but we just need to set certain standards, right? So very briefly overall, method-wise, Thomas mentioned the PDS earlier, and I think there will be more on that later today, so I won't deep dive into it, but it's the product disposal specification. So basically this contains all the information you would need on the blade in order to actually take care of it after end of life. We got that information from LM, and then how we approached it was that we went to first H.J. Hansen and said, if you actually had to deal with this project with the technologies you have available today, given the input that I just presented before, how would you then approach it? And then we started documenting and gathering data on that. The same for the pyrolysis processing with the help of McKean Energy, and cement co-processing, we worked with F.L. Schmidt. So again, very hands-on. What would you do if you received these 300 tons of material through the door tomorrow? And we use that as the guide, or as the baseline. Then what we've done at SDU, and I have my colleague Samane here today as well, we've been working on life cycle assessment through first documenting these material flows with the help of the partners, and then using this information to make life cycle assessments. And for those of you who are not that familiar with LCA, it's basically where you take everything involved in the process into account and see what are the impacts environmentally from conducting all these. And it's quite complex, so I won't go more into that today. And then finally, we also worked on preliminary cost evaluation. Again, we're working with technologies that are not final yet, so this is a bit of a difficult exercise, but to try and get the first feeling of where are we also cost-wise. So this is what I will then present in terms of the documented value chain we have found based on all this I presented already. So we have the first scenario up here, being landfill, and as I said, it's not something we desire, but it's something we want to compare against. In the top you can see overall 8 steps. The first step being preparation. Before any project, there are some activities that must be in place, but we start the project when the blades are in the port. So we don't account for taking down the blade or any of those things, because they would be the same in all scenarios anyway. Then in step 2, we need to pre-process to the extent that we can actually transport the material. So it's, you can say, sectioning for transportation. Then the third step, we need to transport it. And here we assume we're using H.J. Hansen's site in Taulo. So we're transporting it to that, where in step 4 it's further cut into smaller sizes, so we can in step 5 actually shred the material. Then after step 5, it's transported to Bremen, as I showed on the map before. And here it goes through the final processing in step 7, and that differs between the different technologies, of course. And then finally in step 8, you have an end product that can be sold to potential off-takers. So the first scenario here, landfill, you go through, of course, the preparation activities, and then again, you still need to transport it, so you need to reduce the size, but then it's taken directly to the landfill site. In the second scenario, being mechanical shredding, you go through step 1 to 6, so you cut it up on site, move it to Taulo, cut it even further, then put it through a mechanical shredder, again transport it to a location where it's assumed in this case to be used as a substitute for gravel. In the third scenario, pyrolysis, again step 1 to 6 are identical, so I won't go through those again, but then it goes through the pyrolysis process where this material is used as a feedstock. It goes through the condensation process and fiber processing, and then you end up with these 3 output end products being gas, oil, and fibers. And I know there will be more on the pyrolysis process later, so again I won't deep dive here. And then finally cement co-processing, again step 1 to 6 are still the same, but then we have some other processes here. First the material is mixed with some other components, then grinded, then it goes through the pyro processing and cement grinding, and then finally you have the end product being cement. So this is what we're working on, gathering data, doing the LCA analysis, and unfortunately I can't present any of those results today, but this is ongoing work. And the final, you can say the next steps is that we're still working on data refinement together with the partners, because the better the data, the better the model. We also need to keep investigating the different technologies. We actually have the blade available, so we can start doing some testing. So we're also going to see how does that actually compare to the assumptions we've done. And finally, we need to evaluate and determine what do we then actually based on our results, what do we need to improve. So that was briefly what we're working on right now. As I said, you are very free to contact me or the other, my colleagues from SDU, if you have any questions, and then hopefully you have some questions. At least that's what I'm proposing now. Thank you. Yeah?
One question. What's the timeline for the next step? When do we expect to be able to present some LCA for those different scenarios?
Yeah, so for internal purpose in the project, we expect to have the preliminary results quite shortly. So before, you can say during this fall. But again, we still need to refine data even more, so before we can actually publish anything and share it. I don't know exactly how long time that would be. It depends on how much work we need to do to get the data. So unfortunately, it will probably be a little while yet, but yeah. Yeah.
Thanks. It was really interesting, and I'm really looking forward to the results. And do you already have any estimations on the prices or the value of the fibers after the pyrolysis process?
I think specifically for the pyrolysis process, maybe it's more Irene that can answer that later. But we are working with preliminary prices, yes. But as I said before, it's preliminary because the technologies are still quite on an emerging level, and of course there are some costs related to upscaling and so on, and how is that accounted for. So in the project we are working with some preliminary tipping fees to kind of get some kind of feeling of what are we working, I mean, what would the end result be, but there's still quite a lot of, you can say, learning, that is required here, but we use it as a guideline, yeah. Thank you. Anything else? Otherwise, you're very welcome to come and speak to me afterwards.
Thank you, Kristine.
Thank you. No, thank you.